me, Assistant Professor, Department of Mechanical Engineering, BMS College of Engineering, Bangalore. Now, I'll be talking about operations performed on lathe. Before that, I'll just give a small introduction about lathe machine. So, this diagram shows a typical lathe machine. So, a lathe machine is a machine tool employed generally to produce circular objects. It is said to be the mother of all the machine tools since it is so versatile that almost all the machining operations which are performed on the other machine tools like drilling, grinding, shaping, milling can be performed on it. Various types of lathes are being used in practice to perform variety of machining operations. The spindle is the part of the lathe that rotates. It is driven by an electric motor through a system of bell drives and gear trains. So there are various work holding devices that holds the job. So few of them are like the workpiece is held between the two centers and it is driven by a device called a dog. This method is suitable for parts with high length to diameter ratio. And the other one is the three-jaw self-centering chuck, which is used for most operations on cylindrical work parts. For parts with high length to diameter ratio, the part is supported by center on the other end. So there are a few important components in a lathe as you can see in this diagram. So the few important parts are like bed, headstock, tailstock, carriage, feed rod, lead screw. So these are the important parts in a lathe machine. So talking about a few important functions about these parts, headstock is also called as a life center. So this is fixed to the bed and is equipped with motors, pulleys and V-belts that supply power to a spindle at various rotational speeds. And the other part is the bed, where the bed supports all major components of the lathe. Beds have a large mass and are built rigidly, which is usually manufactured by using a cast iron. And the other part is the tailstock, which is also called as a dead center. So this tailstock can be used to support the end of the workpiece with a center or to hold tools for drilling, reaming, threading or cutting tapers. It can be adjusted in position along the ways to accommodate different length of workpieces. And the other part is the carriage, which controls and supports the cutting tool. And it consists of a saddle that slides along the ways, and it has an apron which has the complete control of the feed mechanisms, a cross slide that controls traverse motion of the tool, and a compound tool post that adjusts to permit the angular tool movement, that is during the machining of the workpiece. And there's a tool post that holds all the cutting tools on it. So with that, the machining of the workpiece can be done. So this is just the brief introduction about the lathe and the different parts in it. Now let me start with the main topic, that is the operations performed in a lathe machine. So these are the few important operations which can be performed in the lathe machine. To name a few, they are like plane turning, step turning, face turning, taper turning, where we have three different methods in taper turning, thread cutting, knurling, and the other operations like drilling, boring, reaming, etc. So let me start with the plane turning. So plane turning, as you can see the definition, it is the operation of removing the excess amount of material from the surface of a cylindrical job. So this turning may be performed upon a workpiece supported in a chuck, but the majority of workpieces turned on an engine lathe are turned between the two centers, that is the life center and the dead center. Turning is the removal of metal from the external surface of a cylindrical workpieces using various types of cutter tool bits. Turning can be done manually in a traditional form of lathe, which frequently requires a continuous supervision by the operator, or by using an automated lathe which does not. This diagram, you can see a plane turning which is performed on a cylindrical object. So this is the movement of the tool here, and this is the workpiece where the turning operation is performed. So the next operation is the step turning. So step turning is nothing but the removal of the material in a cylindrical object, and you can get a desired diameter at a different intervals. So if you can see in this diagram, you can see three step turnings which is done on a cylindrical object. So this step turning, like each of the part will have a different diameters, but it is on the same workpiece. So this kind of operations can be performed in a lathe machine by using the same tool as that of a turning. And the next operation is the face turning. So this is also called as a facing. So the facing is a machining operation by which the end surface of the workpiece is made flat by removing metal from it. The workpiece is held in the chuck and the facing tool is fed either from outer edge of the workpiece to progressing towards the center or the vice versa. The cutting tool is held by a tool holder in a tool post. There is an axial movement of the tool and that can be avoided by locking the carriage. So this diagram you can see a facing operation which is performed on a lathe machine, and this is about the facing. And the next one is the taper turning. So a taper turning is nothing but an operation which is performed on a lathe machine, and that feeds a tool at an angle to the length of the workpiece in order to create a conical shape. So in ordinary straight turning, the cutting tool moves along the line parallel to the axis of the work. Here the cutting tool will move at a certain angle towards the workpiece in order to produce some taper on the workpiece. Therefore, to turn a taper, the work must either be mounted on a lathe so that the axis upon which it turns, it has an angle at the axis of the lathe. A taper, it can be either an external taper or an internal taper. If a workpiece is tapered on the outside, it has an external taper. It is tapered inside, it is called as an internal taper. The method used for turning a taper depends upon the degree or a length or a location of the taper on the workpiece. There are three important methods in this taper turning. So one is the swiveling the compound rest, and the second one is the offsetting the tailstock, and the other one is the taper attachment. So let me talk about the first one, that is swiveling the compound rest. So in swiveling the compound rest, it is generally used for turning the short steep tapers, but it can also be used for the longer and the gradual tapers. This method can be used with a high degree of accuracy. The compound rest base is graduated in degrees and can be set at a required angle for taper turning operations. And the next method is the offsetting the tailstock. So in offsetting the tailstock method, this method is also called as a set over method. Here the tailstock center is set out of the alignment. The workpiece gets taper turned because its axis will be inclined at an angle with the longitudinal movement of the tool, which will be parallel to that of the lathe bed. The entire carriage is to be moved parallel to the lathe bed to cut the taper. Here the advantage of this method is to use of power feed for a better finish and ability to do the longer tapers on the workpiece. The disadvantage of this method is that it takes time to adjust the tailstock and it can cut very shallow angles. So, and the last method is the taper turning attachment. So this attachment is used again for the taper turning operation. It is bolted to the back of the carriage saddle in operation. It is connected to the cross slide so that it moves the cross slide laterally as the carriage moves longitudinally. This action causes the cutting tool to move at an angle to the axis of the workpiece to produce a taper. Here the taper turning attachment, this method has some special value or the features. So this here the lathe centers remain in alignment and the center holes in the work are not distorted. The length of the work need not be considered because once the taper attachment has been set, that particular taper will be turned on any piece of any length. So these are the three different methods in a taper turning operation. And the next operation which can be performed on a lathe machine is the thread cutting. So the thread cutting operation is nothing but it is formation of a helical ridge on a cylindrical or a conical rod. It is cut on a lathe when a tool ground to the shape of the thread is moved longitudinally with a linear motion on the workpiece. So you can see in this diagram how a thread is being cut on a cylindrical object with the help of a different type of a cutting tool. And talking about the next operation, that is the knurling. So knurling is defined as an operation which is performed on a lathe to generate the serrated surfaces on workpieces by using a special kind of a tool which you can see here, which impresses its pattern on the workpiece. So this pattern might be of a diamond or a straight lines pattern. So the main use of this knurling operation is to provide a grip to hold the part of the workpiece. So the other diagram shows a pattern which is generated on the workpiece, that is produced with the help of the knurling tool. And there are few other operations which can be performed, like as I already said, it is drilling, boring, reaming. So drilling is nothing but generating a hole on a cylindrical object. Since this operation is performed on a lathe, so on a cylindrical object you can generate a hole. So the difference between the drilling machine and this operation here is, here the drill bit will be stationary and the workpiece will be rotating, and the drilling machine it is vice versa. And boring is nothing but enlarging a already drilled hole, that is by using the different kind of a tool which can be performed on a lathe machine. And the last operation is reaming. So this is nothing but a finishing operation that is used to generate a finishing, to provide a clean finish to a hole which is already drilled. So by this I'll conclude my lecture.